welcome to our next lesson, which is solving linear equations and inequality in one variable. Our most essential learning competencies are: the learner first find the solution of linear equation or inequality in one variable. Second, solves linear equation or inequality in one variable involving absolute value by graphing and algebraic methods. Third, solves problems involving equations and inequalities in one variable. To begin our lesson, we should know that solving equation or inequality is finding the value or values of the variable that will satisfy the equation or inequality. The equation x plus 5 is equal to 12 is a mathematical sentence that is a conditional equation because it can either be true or false. It can only be true if x is equal to 7. By substituting 7 to x, you have 7 plus 5, which is equal to 12. Both sides of the equation name the same number, which is 12, because 7 plus 5 is equal to 12, which is equal to 12. Thus, 7 is called the solution of the equation, or sometimes it is called the root of the equation. The inequality x plus 5 less than 12 can either be true or false too. The value of x that will make the inequality true are numbers that are less than 7. If you replace x with 6, which is less than 7, then 6 plus 5, which is less than 12, so 6 plus 5 is equal to 11, which is really less than 12. You can substitute any number to x as long as it is less than 7. You have to consider properties of equality or inequality before you can solve an equation or inequality. For any real numbers a, b, and c, here are the properties of equality. The first property that we have is addition property of equality, or APE. If a is equal to b, then a plus c, which is equal to b plus c. The next property that we have is multiplication property of equality, or MPE. If a is equal to b, then AC is equal to BC. The next property that we have is reflexive property of equality. Any number or expression is equal to itself. 3 is equal to 3, m is equal to m, x is equal to x. That was reflexive property of equality. The next one is symmetric property of equality, or SPE. The sides of the equation can be interchanged. If AB is equal to CD, then CD is equal to AB. The next property that we have is transitive property of equality, or TPE. If two equations are equal to a third quantity, then they are all equal to each other. If A is equal to B and B is equal to C, then A is equal to C. The next that we have is the properties of inequality. So we have the action of comparison. We have A, which is less than B, A, which is equal to B, and A, which is greater than B. Then we have the transitive property of inequality. If A is less than B and B is less than C, then A is less than C. Then we have if A is greater than B and B is greater than C, then A is greater than C. C. Next is addition property of inequality, or API. So if A is less than B, then A is equal to C, which is less than B, plus C. The next property that we have is multiplication property of inequality, or MPI. If A is less than B and C is greater than 0, then AC is less than BC and A over C is less than B over C. Another is if A is less than B and C is less than 0, then AC is greater than BC and A over C is greater than B over C. And another, if A is greater than B and C is greater than 0, then AC is greater than BC and A over C is greater than B over C. And last but not the least, if A is greater than B and C is less than 0, then AC is less than BC and A over C is less than B over C. For example, of an addition property of equality, or APE, if x plus 5, which is equal to 4, then x plus 5 minus 2 is equal to 4 minus 2, or x plus 3 is equal to 2. Because x plus 5 minus 2 is equal to positive 3, so we have x plus 3, which is equal to 4 minus 2 is equal to positive 2. Therefore, we have x plus 3, which is equal to positive 2. Another example is for multiplication property of equality. So we have, if x is equal to 10, then 2 times x is equal to 2 times 10, or 2x is equal to 20. For addition property of inequality, we have if x minus 2 is less than 6, then x minus 2 plus 2, which is less than 6 plus 2, or x is less than 8. Then we have the multiplication property of inequality. If negative x is less than 3, then negative 1 times negative x is greater than negative 1 times 3, or negative 1 times negative x is x, which is greater than negative 1 times 3 is negative 3. Moving on to our discussion, we have the linear equation in one variable. To solve equations, we apply the properties of equality and follow some steps. The first step that we have is simplify both sides of the equation. This includes applying distributive property of multiplication over addition, or DPMA, or combining similar terms. The second one, if the equation has a fraction, clear the denominators by multiplying both sides of the equation by the LCD, or least common denominator of all the denominators. The third one, if equation has decimal, clear the decimal by multiplying every term of the equation by powers of 10, depending on the greatest number of decimal places in the term has. The fourth step, if a constant is added to a term with a variable, add its opposite to both sides of the equation, or apply APE. The fifth one, if a variable has a numerical coefficient other than 1, multiply both sides by the reciprocal of the numerical coefficient or divide both sides of the equation by the numerical coefficient or by MPE. And last but not the least, substitute the solved value to the variable in the equation to check if you get the right answer. For our example, we are going to solve for the value of x. First example, we have 2x plus 5, which is equal to positive 21. For our solution, since the equation is already in simplified form, then we're going to go on step number 4. So by APE, we're going to get the opposite of 5, which is negative 5. We have 2x plus 5 minus 5, which is equal to 21 minus 5. So we're going to simplify that. Then we have 2x plus 5 minus 5 is equal to 2x, and 21 minus 5 is equal to positive 16. Therefore, we have 2x, which is equal to 16. Then by APE, so the reciprocal of 2 is 1/2. Therefore, we're going to multiply both sides by 1/2. So we have 1/2 times 2x, which is equal to 1/2 times 16. So we're going to simplify that. So the solution of the equation is x, which is equal to positive 8. So to check that, we have 2x plus 5, which is equal to 21. So we're going to substitute the value of our x, which is positive 8. So we have 2 times 8 plus 5, which is equal to positive 21. Then we have 2 times 8 is equal to 16 plus 5, which is equal to 21. Then we have 16 plus 5 is equal to 21, which is equal to 21 also. For our second example, we have the sum of 3 consecutive odd integers is 81. Find the numbers. For our solution, the difference between 2 odd numbers is 2. If x is the first odd integer, then x plus 2 is the second odd integer, and the third is x plus 2 plus 2, or x plus 4. Since the sum of these numbers is 81, then the equation is x plus 2 plus x plus 4, which is equal to 81. So we're going to combine similar terms. Therefore, we have 3x plus 6, which is equal to positive 81. Then, by APE, so we have 3x plus 6 minus 6, which is equal to 81 minus 6. So we're going to get the reciprocal of positive 6, which is negative 6. So we're going to subtract both sides by 6. Then we have 3x plus 6 minus 6 is equal to 3x, and 81 minus 6 is equal to 75. So by MPE, multiplying both sides by 1/3 or dividing both sides by 3. So we have 3x divided by 3 is x, and 75 divided by 3 is equal to 25. Therefore, x is equal to positive 25. So the first number is x, which is equal to 25. The second number is x plus 2. Therefore, 25 plus 2 is equal to 27. Third number is x plus 4. Therefore, 25 plus 4 is equal to 29. Check if the sum of these odd numbers is 81. So we have 25 plus 27 plus 29 is equal to positive 81. For For our third example, Anton is 2 more than 3 times older than her daughter Zach. In 16 years, he will be twice as old as his daughter. What are their present age? For our solution, we're going to use the tabular form. So we're going to have Sam and Anton, their present age, and their age 16 from now. So we're going to let x as daughter's age. X plus 16 is age 16 years from now. Then we have 2 more than 3 times is equal to 3x plus 2, which is Anton's age. Then twice as old in 16 years is equal to 2 times x plus 16. In forming an equation, consider equating the same quantity expressed in different way. In this case, you can equate Anton's age 16 years from now. So we have 3x plus 2 plus 16 is equal to 2 times x plus 16. So we're going to simplify both sides. So we have 3x plus 2 plus 16 is 3x plus 2 plus 16 is 18, which is equal to 2 times x is positive 2x, then 2 times 16 is positive 32. So we have 3x plus 18, which is equal to 2x plus 32. So by APE, we're going to get the opposite of positive 18 first, which is negative 18. So we have 3x plus 18 minus 18 is equal to 2x plus 32 minus 18. So simplifying both sides, so we have 3x plus 18 minus 18 is 3x, which is equal to 2x plus 32 minus 18 is 2x plus 32 minus 18 is positive 14. Therefore, we have 3x, which is equal to positive 2x plus 14. Then by APE, to combine 3x and 2x, so we're going to get the opposite of 2x, which is negative 2x. So we have 3x minus 2x is equal to 2x minus 2x plus 14. Therefore, the age of Sam now is 3x minus 2x is x, which is equal to 2x minus 2x plus 14 is 14. Therefore, the age of Sam now is 14, which is x is equal to positive 14. Then the age of Anton now, we have 3 times 14 plus 2, which is equal to 44. And that is age of Anton now. Then to check, if Sam's age now is 14, her age in 16 years is 14 plus 16 is equal to 30. If Anton's age now is 44, his age in 16 years is 44 plus 16 is equal to 60. So the age of Anton is twice as the age of Sam's 16 years from now, which is the condition in the problem. Moving on to the linear inequality in one variable. To solve inequality, you have to use the properties of inequality and follow the same steps in solving for the equation. For our example, so we're going to solve for x. First one, we have x over 3 plus 4, which is greater than 5. Our solution, we're going to clear fraction by multiplying each term in the inequality by the denominator, which is 3. So we have our inequality x over 3 plus 4, which is greater than 5. So we're going to multiply each term of the inequality by our denominator 3. So we have 3 times x over 3 plus 4 times 3, which is greater than 5 times 3. So we have 3 times x over 3 is x plus 4 times 3 is positive 12, which is greater than 5 times 3, which is equal to positive 15. Therefore, our new inequality is x plus 12, which is greater than 15. So by API, so we have x plus 12 minus 12, which is greater than 15 minus 12. Therefore, our x is greater than 3. So the solutions of the inequality are all numbers that are greater than 3. The solution of the inequality can be written in different ways. The first one is the set notation. So it is read as set of all x such that x is greater than 3. The next one is the interval notation. The symbol means infinity. The next one is the graphical method. So we have x is greater than 3. So take note that the point that corresponds to 3 is not solid. This means that 3 is not included in the solution set of the inequality. The point must be solid if the number corresponding to that point is included as one of the solutions of the inequality. For interval notation, a bracket is used if the number is a part of the solution set. Suppose the inequality is x over 3 plus 4, which is greater than or equal to 5. The inequality is equal or greater than. So the solution is x, which is greater than or equal to 3. So by set notation, we have x such that x is greater than or equal to 3. By interval notation, so the bracket is used to indicate that 3 is included. Then we have the graphical method. So the point that corresponds to 3 is solid, which means that 3 is included. For our second example, find the value of x that satisfies both inequalities, negative 3, which is less than 2x plus 1, and 2x plus 1, which is less than or equal to positive 9. So for our solution, you can write the inequality as 2x plus 1, which is greater than negative 3, but less than or equal to positive 9. So by API, we're going to get the opposite of positive 1, which is negative 1. So we have 2x plus 1 minus 1 is greater than negative 3 minus 1, but less than or equal to 9 minus 1. So we're going to simplify that inequality. So we have 2x plus 1 minus 1 is equal to positive 2x, which is greater than negative 3 minus 1 is negative 4, which is less than or equal to 9 minus 1, which is 8. Therefore, we have 2x, which is greater than negative 4, but less than or equal to positive 8. So by MPI, so we're going to divide both sides by positive 2. So we have 2x divided by 2. So we have x Then we have greater than negative 4 divided by positive 2 is equal to negative 2, but less than or equal to 8 over 2, which is equal to 4. Therefore, we have x is greater than negative 2, but less than or equal to positive 4. The solution set are numbers between negative 2 and positive 4, including 4. For our set notation, x such that x is greater than negative 2 but less than or equal to positive 4. For our interval notation, parentheses means that negative 2 is not included in the solution set, while bracket means that 4 is included in the solution set. For graph, the point that corresponds to negative 2 is not solid, while the point that corresponds to positive 4 is solid. For our third example, the length of the rectangle is 4 more than twice the width. If the perimeter is not more than 80 cm, find the possible dimensions of the rectangle. For our solution, let x be the width. Then we have 2x plus 4 is the length, which is 4 more than twice the width. So our perimeter is equal to 2 length plus 2 width. However, in the problem, it must not be more than 80. So we have 2 length plus 2 width is less than or equal to 80. The perimeter can be 80 but not more than 2 times 2x plus 4 plus 2 times x, which is less than or equal to 80. So we have 4x plus 8 plus 2x. Because we have 2 times 2x is 4x, then 2 times 4 is equal to positive 8 plus 2 times x is 2x, which is less than or equal to 80. So we're going to simplify that. So we have 4x plus 8 plus 2x is 6x plus 8, which is less than or equal to 80. So by API, so we're going to get the opposite of positive 8, which is negative 8. Therefore, we have 6x plus 8 minus 8 less than or equal to 80 minus 8. So we have 6x plus 8 minus 8 is 6x, which is less than or equal to 80 minus 8 is equal to 72. Therefore, we have 6x, which is less than or equal to 72. So by MPI, so we're going to divide both sides by positive 6. Therefore, 6x divided by 6 is equal to x, which is less than or equal to 72 divided by 6 is equal to 12. Therefore, x is less than or equal to positive 12. So the possible width is greater than 0 but less than or equal to 12, since there is no negative measures. Since length is equal to 2x plus 4, if x is equal to 0, then the length is 4. However, the width must be greater than 0. Therefore, the length is greater than 4. The highest possible width is 12. Then, the length is 2 times 12 plus 4 is equal to 28. Therefore, the length can be equal or less than 28. The possible length is greater than 4 but less than or equal to 28. So the possible dimensions of rectangle are the width is 12, the length is 28. another width is equal to 11, and length is equal to 26, and etc.